Alright, the next concept we're going to be looking at is something called address binding. So, in some programming languages, for example C, you declare a variable first and then you have to use it, right? So we have this syntax int x, which means, and when we're learning C programming, for instance, and when our teacher say writes a code where there is this line, where they use this line, and when they're explaining that code fragment, what they say is this line creates some space in the memory and allocates it to the variable x, so that subsequently when you get a value as input or when you assign something, that goes and sits in the place which was created in memory. So that is how this line is explained when we are first taught basics of programming, right? So when I ask the computer to create something like this, and when that line is compiled or interpreted and executed, at that time this variable needs to be mapped to a specific location in memory. So the moment I write int x semicolon on my text editor or whatever, the computer is not immediately going to allocate some space in the memory. I might write the program today, I might save it, but if I'm going to compile and run it 10 days later, that is when the memory is going to be allocated to this variable called x, right? So when I compile and run a program, for example, memory needs to be allocated for my variables. And my programs themselves, generally they lie on your disk. They could be your hard disk, your C drive, D drive, whatever. When you want to run a particular program, it is first loaded from your disk onto your main memory and then it is executed, right? So this again is something you might know from computer organization. If you're not familiar with this point, let me reiterate. Most of your data, because your main memory, and by main memory I mean RAM, right? So your RAM is limited. Of course it can be in gigabytes, but it is still limited. So all the data you want to store on your computer cannot be put into the RAM. So most of the time your data resides in your disk, which is your secondary memory, your hard drive, your C colon, D colon, all of that. So when you want to execute a particular process, that process is loaded from your disk onto the RAM and it is executed. This is very similar to the cache memory idea which you studied in computer organization, right? Whatever is in your main memory and you want to access it faster, you bring it from the main memory to this thing called cache memory. Similarly, same logic, you have all your data on your disk and from there you will bring whatever you want to execute to your main memory and then execute it, right? So in your disk again you will have specific memory locations. It's not like your programs are randomly thrown at random locations in the disk. So within your disk they have specific locations which are identified by some address or some numbering system, something is there. So from there you bring it to the main memory, again from that address system or that numbering or identification system to your main memory address, there should be a mapping, right? So address binding takes care of all of that. So address binding is basically a mapping from one address space to another. Address space as in a set of memory locations. The memory locations could be your main memory, could be your disk, it could be your pen drive, CD, all of that. It could be your cache memory, it could be your registers, anything. From one set of addresses, from one address space to another address space when you are bringing some data and when you are mapping. So whatever data was present at 1001 on my disk, that is now coming to location 500 on my main memory. Whatever was present at 1010 on my disk is coming, let's say, to 525 on my main memory. So that mapping is what we call address binding, which is necessary, right? When you're taking something, you need to take your data from specific locations in your disk, you need to put it on specific locations in your main memory. Similarly, if you are dealing with variables, they need to be allocated a specific address in your main memory, and all of this locations in main memory is what will constitute your process address space. So this address binding is an important concept and it is generally done by these programs called linkers and loaders. Now we will not be looking at linkers, loaders in much detail because that is not the objective of this course. Address binding itself is not something we're going to look at in too much detail. but you need to know what address binding is, which is basically a mapping from any one address space to another. And there are three types of address binding which we will quickly look at. So the three types of address binding are compile time, load time and execution time address binding. So what happens is, like I said, let's say I'm writing a C program, I'm saving it somewhere in my disk, C colon or whatever. It will first be loaded onto my main memory, then it will be compiled and then it will be executed, right? So this address binding can happen either as soon as it is loaded, or when it is being compiled, or when it is being executed, right? So the general sequence of things is load, compile, execute, but we will look at address binding in this sequence: compile time, load time, execution time. So these are three types. It's not a sequential thing. Address binding can happen at any one of these three phases, right? So in compile time address binding, what happens is, if you know where the process will reside in memory, then absolute code can be generated. So my C program is in my hard disk. If my compiler knows, or if my operating system actually, if my OS knows that this program is going to go sit in this register of my main memory only, then it can give absolute code, as in it can allocate address space starting from that location up to so many places. So if my OS knows that whenever I load this program from my disk, whether it is today or 10 days later or next month or next semester, it is always going to come and sit at this register or this spot on my main memory only. If my OS knows this for sure, then when the program is being compiled, it will allocate memory starting from that location, let's say R1, up to so many places. So that if that happens during compile time, we call it compile time address binding. Now if your OS is not sure, so let's say the OS has this doubt, so today if she is loading this program, it is going to be located at this R1 location. Next week if I'm loading the same program, it might take up another location on the main memory. So if that ambiguity is there, what the OS is going to do is, it will make the compiler generate something called relocatable code. So initially a sort of temporary address is created, and then finally when everything has been loaded for that particular time, when all your header files, everything has been loaded, the address binding takes place. So it is like a stopgap arrangement kind of a thing. So for example, for those of you who are, let's say, coming into the hostel newly at the start of a semester, let's say your wardens are not exactly sure which room number will be allocated to you, because some procedure is still going on, some paperwork is still being sorted out. For time being, because your semester is starting and you've come to campus with all your luggage, you will be given a temporary room, probably whatever room is available in one of the hostels. It might not be the kind of room you asked for, might be with roommates who are not from your year or your department, but as a stopgap arrangement, you'll be given a temporary room. Once all the paperwork is sorted out, you will be allocated a room according to your preferences, your choice of, AC, non-AC, sharing, whatever, right? So that kind of a thing, because there is this ambiguity initially as to which place this person is going to occupy, because some processes are going on in the background. Same thing here. So if your OS is not sure that this process will definitely go occupy this place only, then something called a relocatable code will be generated, which is like a stopgap arrangement. So a temporary location will be given, and then once whatever needs to be loaded is all loaded, it will be given a final position in the memory, and accordingly memory addresses will be generated and address binding takes place. Or the third thing is execution time. So if the data is going to be moving, so it's not like it comes to R1 and it sits in R1, it might be moving during runtime from this location to that location. Like if your program entails something like that, you swap the values of two variables or something like that, which involves data being transferred from one location to another, then you cannot beforehand decide this is the memory location and allocate it. So in such cases, address binding happens during execution time. So I know this might not have made complete sense. Address binding, to understand it fully, we need to have a better knowledge of linkers, loaders, and address binding itself is not the objective of this course. So all you need to know is that address binding is a sort of mapping from one address space to another, and it is one of the things which the operating system deals with. So it can do it either at compile time, if it is absolutely sure where to put the process, or at load time it can first make a stopgap arrangement and then later transfer things to their final location if it is unsure, or if there is an element of moving about involved, then address binding will happen only at execution time. So that much of an understanding about address binding is sufficient for the purposes of this course.